In example 3, we're going to start working with word problems. Now, before we start with the actual problem, I want to go over some things to think about with word problems. The first thing, to find the slope in a word problem, you're going to look for a rate of change or something that is happening for every x variable that you have. So once you determine what x is, if you find a number that's happening for every single thing, for instance, if x was hours and you have something happening every hour, then you know that that's going to be your slope. Okay, so you're looking for rate of change or something that's happening for every one of your x variables. To find the y-intercept, those are our two things that we're looking for. To find the y-intercept in a word problem, you're going to look for a starting point, an initial amount, a flat fee, the beginning. So your y-intercept always represents the beginning, the start of something that you're talking about. Remember that x is going to be our independent variable and y is going to be our dependent variable for these problems. Now let's take a look at example 3. It says the number of trout in a lake was estimated to be 44.5 thousand in 1995. During the next 10 years, the trout population is expected to increase by about 3.2 thousand per year. Write an equation to model the trout population in any year between 1995 and 2005. Let t be the number of years since 1995. So let's go ahead and write out our variables. That's the most important part. So we are given the first one. We know t is equal to the number of years since 1995, which means y is going to be equal to the trout population. Since y is the trout population, that's our dependent variable, it depends on the number of years, that means t is going to be our x, our independent variable. So what we need to come out with our word problem is we need a slope and we need a y-intercept. Our slope is going to be something that's happening for every year. Remember, slope is something that's happening for every x. So since x in this case is the number of years, we're looking for something that's happening every single year. Well, if we look at our problem, it says the trout population is expected to increase by 3.2 thousand per year. Per every, that indicates that this 3.2 thousand is happening for every year, which tells us that that's our slope. So we know that m is equal to 3.2 thousand. Then we're looking for our y-intercept. And our y-intercept is going to be that initial amount, the starting point, the flat fee. So if we're talking about a trout population, we want to know what's the beginning population before we start calculating things. And right here it says the trout population was 44.5 thousand in 1995. And 1995 is the first year we are starting. So we know that our y-intercept, our beginning, is 44.5 thousand. And then what we want to do is we want to write our equation. Remember, we're trying to fill in for y equals mx plus b. So we are still using y. So we're going to continue to use y. Equal to, m in this case is 3.2. In this case, instead of using x, we're using t. So I'm going to put a t in for my x. And then my y-intercept is 44.5. So here's the equation that represents this situation. If we scroll down a little bit, our next problem here says to predict the trout population in 2002. So let's think about it. If we started in 1995, that means 1995 is year 0. Which means 2002 would be year 7. So that tells us that our t value, our number of years since 1995, is 7. And we're going to take that 7 and we're going to plug it into our equation right here. So we get y equals 3.2 times 7 plus 44.5. And if you plug that into your calculator, you'll get 66.9. One thing we have to remember is both of these numbers represented 1,000. So our answer here would be 66.9 thousand trout. If you have questions on this problem, let me know.